All right, let's do it. I want to do it wrong. I'm not going to write anything down when I do it wrong, okay? But I want to talk about the way people would perceive this. Given the graph of f prime below, I think there should be a comma there, and we should not start a new sentence. And we'll under capitalize answer. There we go. Things to fix for later. Answer each of the following corresponding questions. State all intervals where the graph of f is increasing. You might be tempted, this is wrong, don't do this. You might be tempted to say the graph is increasing here and here. No, it's not. No, it's not. Why not? This is not f. This is the derivative. If it helps, you don't have to do this, but if it helps, you could draw a number line. And we're dealing with the closed interval, by the way, from -6 to positive 11. -6 to positive 11. So none of this infinity, negative infinity, infinity stuff. And the graph is the derivative. The derivative equals 0. Yeah, we're finding where the derivative equals 0. There, -5. And we're going to determine, based on what we see, where the derivative is positive or negative. Here, the derivative is negative. And I know you're looking at it saying, but the graph is going up. No. Yes, the graph is going up, but that's not what we're looking for. We are looking for where the derivative is positive, above the x-axis, or negative, below the x-axis. From -6 to -5, the derivative is negative. Increasing, but negative. From -5 to +3, the derivative is positive. From 3 to 9, the derivative is negative. And from 9 to 11, it sounds like time. From 9 to 11, it's going to be out of the office. It's positive. Because, let's reword this. Derivative is below the x-axis. Derivative is above the x-axis. Derivative is below the x-axis. Derivative is above. You don't have to write all this, but it helps us articulate what's about to happen. State all intervals where the graph of f is increasing. Now things get really easy. Let's switch to a blue pen. Don't know why. That would be from -5 to 3, along with the interval from 9 to 11. Where's the graph decreasing? Glad you asked. -6 to -5, as well as 3 to 9. Okay, state all x values in the open interval from -6 to 11. Okay, now we're saying, well, let's just pretend like we're not going to count those at the ends, because that's just going to get tricky if we do. Where the graph of f achieves a relative maximum, justify your answer. So let's just kind of go through here and figure them out. Right here, here, and here are going to be potential answers for this question and the next one, because maximum, minimum, same question, just different word. And you can see where the light is kind of shimmering through. Such a illustrious, illuminating lesson. Okay, our graph of f that you don't see here transitions from decreasing to increasing. So this is a minimum, and this is also a minimum. And this one is a maximum. Now we know the answers, but let's justify it. So state all x values on the open interval from -6 to 11, so just these three are my options, where the graph of f achieves a relative maximum. That would be this. So x equals 3 is a relative max because f prime changes from positive to negative. This is excellent practice for free response questions. Which you could also, well, use what they gave you. Let me say that. This is the best answer. Another way of wording it that does not directly assess or address what they gave you, which was the derivative. Another way of wording it would be the graph changes from increasing to decreasing. But they didn't tell you that. You implied that based on what they gave you. So use what they gave you. Okay, same idea here. X equals -5 and +9. And why? Those are relative minimums, and you can abbreviate and make it plural at the same time, because f prime of x changes or transitions from negative to positive in both of those places, from negative to positive. So the derivative changes, it's like charges, changes from negative to positive. Fun stuff. I like it too.